Assalamu alaikum students. Today we will discuss Boyle's law. This picture is of Robert Boyle. He was a natural philosopher, chemist, physicist and inventor. He is famous for Boyle's law of gases. In 1662, Robert Boyle studied the relationship between the volume and pressure of a gas at constant temperature and put forward a law which is known as Boyle's law. According to this law, volume of a given mass of a gas is inversely proportional to its pressure provided temperature constant. It means that the mass of the gas and the temperature must be kept constant. Then if volume is increased, then the pressure will be decreased, and if pressure is increased, then the volume will be decreased. It means these two properties are inversely proportional to each other. Mathematical representation of Boyle's law is as following. Volume is proportional to 1 over pressure. If we use the symbol of these two properties, then we will write it as V is proportional to 1 over P. It means that the volume is inversely proportional to pressure. If the sign of proportionality is replaced by K constant, then this equation will be written as V is equal to K over P. If we cross multiply this equation, then we will have Vp is equal to K and its value will be equal to constant, where K is the proportionality constant. Now I will explain Boyle's law by this diagram. In this diagram you can see that gas is enclosed in a container which is having a movable piston. The mass of the gas and the temperature is kept constant. You can see that when the pressure on the piston is increased, then the volume is decreased, and when the pressure on the piston is decreased, the volume of the gas is increased. On the right side on the graph is also representing the same condition, that when the pressure is increased, volume is decreased, and when the pressure is decreased, the volume is increased. In this picture, students, you can see that on the left side the container is having gas, its volume is V1 and pressure is P1. On the right side the container is having the same gas, but now its pressure is increased from P1 to P2, and hence its volume is also changed from V1 to V2. This condition can also be represented mathematically as following. For the first container, Boyle's law can be written as P1 V1 is equal to K, and for second container it can be written as P2 V2 is equal to K, where P1 is initial pressure, P2 is final pressure, V1 is initial volume and V2 is final volume. As both equations have the same constant, therefore their variables are also equal to each other. So it can be written as P1 V1 is equal to P2 V2, which is known as Boyle's law. Students, this is known as Boyle's law formula. From this formula, if you know 3 of the 4, you can calculate the force value. Now students, we see experimental verification of Boyle's law. In first container, you can see that the volume of the gas is 1 dm cube and the pressure on this gas is 2 atm. In the second container, when the pressure is increased from 2 atm to 4 atm, then its volume is decreased from 1 dm cube to 0.5 dm cube, that it has become half of the first container. In the third container, you can see that when the pressure is increased from 4 to 6 atm, then the volume becomes 0.33 dm cube, and in the fourth last one container you can see that the pressure on the gas is 8 atm and the volume has become 0.25 dm cube. Now we apply Boyle's formula on 4 of these containers. For the first container, P1 V1 is equal to 2 atm multiplied by 1 dm cube is equal to 2 atm dm cube. For the second container, P2 V2 is equal to 4 atm multiplied by 0.5 dm cube is equal to 2 atm dm cube. For the third container, P3 V3 is equal to 6 atm multiplied by 0.33 dm cube. It's also equal to 2 atm dm cube. For the fourth container, P4 V4 is equal to 8 atm multiplied by 0.25 dm cube is equal to 2 atm dm cube. So you can see that in these 4 calculations for 4 containers, the value of K is constant, that is 2 atm dm cube. It means that the product of pressure and volume remains constant. Now students, if we draw a graph between these values of volume and pressure, this type of graph will be obtained, which shows that the volume and pressure are inversely proportional to each other, keeping mass and temperature constant. I hope students you have got the lecture. Give me feedback and subscribe my channel.